Okay, so to recap, important things on this page, right? I mean, this you all know, and then, the one with the a to the x ln of a is one where people usually forget. These things, okay, remember how they look. Every now and then they will pop up, okay? All right, so let's move on to integration formulas. The first is the power rule again. So basically, whenever you have, like x plus 2 to the power of 2, to integrate, you add 1 to the exponent and you divide by the new exponent. Okay, so that works for anything. The integral of, like if you have the integral, oops. Oh, okay. So if you have like, the integral of, x to the, oh my God, why does it keep doing this? Okay. X to the negative 3, let's say, right? dx, same idea. Add 1, divide by the new exponent. Except if you have the integral to the power of negative 1. Then it's 1 over u du, and the integral is ln of u plus c. Yes? Remember the absolute values. So then we've got the trig functions. And then, so again, this is, like the analogous part to that. This is the integral for a to the x. It's divided by ln of a. And then these are your inverse trig functions. Okay? This, I think you all know pretty well, right? If you have a constant, you can pull out the constant. Integral from a to a is 0. To switch limits, it's negative. This one, if you have the integral from a to c and then c to b, you can just combine it as a to b. Okay, let's take a look at these two. If you have an even function, so for example, this is an even function, right? It's symmetric around the y-axis. Then if you want to integrate from negative a to a, you can just integrate this half, 0 to a, but multiply by 2. Yeah? That's if you have an even function. And then if you have an odd function, so if you have an odd function, like for example this one, and you want to integrate from negative a to a, right? Well, look at what happens here. This and this are equal amounts of area, but of negative sign, so it's just 0. Okay, so that's for an even and an odd function.
When you say even, you like to the power of 2?
No, well, those are even functions, but basically an even function is one that's symmetric around the y-axis. Like a cosine of x is symmetric around the y-axis. Okay, now let's go to some formulas and theorems. Okay, so continuity. So how do you prove or how do you justify that a function is continuous? Well, if a function is continuous, in order for a function to be continuous, it has to satisfy 3 conditions, right? And so remember that. So that's one way of like memorizing a list, right? So first of all, you number your list, and then you remember how many things are on your list, right? So you're like, okay, I needed to have 3 things, So one is f of a has to be defined, limit has to exist, and f of a should equal the value of the limit. Okay, those are the 3 conditions. Now, for number 2 here, how do you show that the limit exists? Well, you have to look at the limit from the left and the right. So you have to say, okay, the limit as x approaches c from the minus side is the same as the limit as x approaches c from the positive side. Therefore, the limit exists. That's number 2. And then you say, is f of a defined? Is it equal to each other? And so on. Okay. Next, intermediate value theorem. Remember this one?
Like if it's bigger on the bottom, this is 0.
That's, no, that's the next thing we're doing. But this intermediate value theorem, basically, it only deals with what is this? F of x. Okay, no derivative here. No derivative. So what does the intermediate value theorem say? If at x equals a, right, let's say y was equal to 3. And at x equals b, y is equal to 7. Then, now let's talk about what the premise is. If f of x is continuous, and at x equals a, y is 3, x equals b, y is 7, then in going from 3 to 7, or in going from a to b, you've got to pass through all of the y's from 3 to 7. Right? Make sense? Yes or no? Okay. So I don't know if I told you this, but like last year or the year before, I was like weighing some flour for, something I was baking. And, I'm very meticulous with my flour, with my measurements when I'm baking, as you could imagine. So, I was like weighing them and like I needed like 400 grams, right? Okay, so, and I had like 397, so I poured in some more and I was like 405. I took some out and I was 398 to pour some in, and I was above 400, and I literally had this like vivid moment where I'm just like, oh my God, like intermediate value theorem says I should pass 400, right? And like that's intermediate value theorem, right? Like if you go from 397 to 403, you've got to pass through 400. Okay, obviously that's taking into, like when you suppose that pouring flour is a continuous function, blah, 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 which it can be, right? If you sprinkle, then it's, continuous. It's not discrete, huh? Oh, yeah. Oh, yeah. I'm very meticulous. Okay. So, all right, so that's intermediate value theorem. So the premise is the function has to be continuous, all right? So as we go through this, we're going to highlight that stuff, and then afterwards we're going to create a chart of, the different theorems and what the premise is. Are they continuous, differentiable, both, none, whatever? Okay. So rational functions, this one you guys already know. Higher exponent on top versus on the bottom. And it has to do with, whether the limit is infinity or it exists or 0. Okay, moving along. Okay, let's talk about this. Horizontal and vertical asymptotes. Now, I know you all know how to find a horizontal asymptote or a vertical asymptote. But if the question asks you, justify why this is a horizontal or a vertical asymptote, all right? For a horizontal asymptote, okay, you have to say, okay, so to show y equals 3 is a horizontal asymptote. You say the limit of f of x as x approaches negative infinity is 3, and the limit of f of x as x approaches positive infinity is 3. Okay? So you have to explicitly state the limit as x approaches positive infinity and negative infinity is 3. Now, for a vertical asymptote, okay, to justify that, let's say x equals 4 is a vertical asymptote, you say the limit of f of x as x approaches 4 from the negative side is, infinity or negative infinity, whatever, okay? And the limit of f of x as x approaches 4 from the positive side is, positive infinity or negative infinity, whatever. Okay? Again, we all know how to find, what do you call it? We all know how to find vertical and horizontal asymptotes. But how do you then like mathematically justify that it's an asymptote? Okay? All right, L'Hopital's rule. Everybody's an expert now. The premise is, it's indeterminate form. And then you can take L'Hopital's rule, and remember, you can continue to use it as necessary. Okay, now, here's where people start to, sometimes things get a little confusing with different functions. Okay, let's talk about average rate of change. Average rate of change is basically slope, as you knew from back in the day, all right? When you do this, it finds the slope or the derivative. Now, this can be helpful, right? It can be used if you're given, what do you call it? A table of values. Right? Remember when we had to find, for example, what's f prime of like 6? Remember there was the tree problem, the height of the tree, and you had to find what's h prime of 6, right? That's the average rate of change. You can use that. Now, here's what you need to like keep in your mind. This is to find average rate of change. So, to find average velocity, well, so how do you find average velocity? Okay, so look. If you do this, is that average velocity? No. What have you found? Acceleration. So, how do you find average velocity? X of b minus x of a over b minus a. So this is average velocity. Okay? This is average acceleration. My point is, in order to find average velocity, the function that goes in here is not the velocity. It's the one, before taking the derivative. Okay? All right. So same with instantaneous rate of change. For instantaneous rate of change, you just take f prime of a. So we use this when you have, yes, when you have f of x given. Okay? So again, to find velocity, you use the derivative of the position and so on. Okay, let's talk about mean value theorem. Ready for mean value theorem? Mean value theorem, our good old MVT. Okay, what is the premise for mean value theorem? F of x has to be continuous on the closed interval and differentiable on the open interval, right? So intermediate value theorem, it was just continuous. This one has to be continuous and differentiable. And then you all know what the what the conclusion is. Okay.
So they're all like kind of the same.
Right. So this basically just combines the two things we talked about, instantaneous and average velocity.
I mean, if you look at it, it's the same.
It's exactly the same thing, because right up here, we talked about average rate of change and instantaneous rate of change. And the mean value theorem says if you have a differentiable and continuous function, then there is one point where these two have to be equal to each other. Okay? So they're very much related. Okay. extreme value theorem. Okay? Extreme value theorem needs a continuous function on the closed interval AB. All right? And it says, this was one of the questions from Sunday. If you have a continuous function, if f is continuous on A and B, then there has to be an absolute minimum and an absolute maximum on that closed interval. Okay? So that's it. All you need is a closed interval and a continuous function. That's all you need for you to just know that there has to be an absolute min and an absolute max. Okay, how do you find the absolute min and max? You have to find the critical points, right? Where are the critical points? How do you find it's where f prime equals what? 0 or undefined. Okay? And then evaluate f of x at the critical points and the end points. So, extreme value theorem only needs the function to be continuous, not differentiable. But do you see why? It doesn't have to be differentiable because the points where it's not differentiable is a critical point, so it's okay. Yeah? Okay. So, increasing, decreasing functions, critical point. Okay, so I'm going to talk more about this when I pass back the tests from Sunday. Okay, like not everything is like a bad omen.
Yeah, like it might be. Like the way.
But we know that it's not.
No.
I did not think about that.
It's not that, no, I just want to like give you like advice on form, but I want to put it in the context of the problem because I don't want to say it like 3 times since we're going to go over those questions anyway. That's all. I'm just efficient here. Yeah.
So you said it's gonna be graded like
Second derivative test. This is a good thing to remember because it can show up in both multiple choice or free response. So basically, if f prime of c is 0 and f double prime is less than 0, so it's concave down, then there has to be a maximum there, right? And so, sometimes like you'll just be given a table of values or something, and they're like, okay, which one of these is true? Okay, it has to have a local maximum there, and so on. This, everybody knows, differentiability implies continuity. Now, this one, the linear approximation will show up like 10% of the time, but we're going to do a couple years of FRQs where I think you'll get enough practice with this one, okay? Inverse functions, same thing. It's not very like prominent on the AP test. What at least, memorize this formula. So if G is the inverse, okay, remember that the slope of the inverse, at least, is the reciprocal of the slope of f of x, right? Because like what slope? Rise over run. Inverse always switches x and y, so it'll be run over the rise, so it'll be the reciprocal. One other thing you have to remember is, again, inverse switches x and y. So in here, you have to look at, f prime of like the y value, not the x value. So you have to switch the x and y values. We're also going to do a couple more of those in the upcoming FRQs. I think we're all good on LRAM and the Riemann sums and the trapezoids, right? Yeah? Okay. Fundamental theorem of calculus. All right. So, if you have the integral of f prime, remember, integral and derivative neutralize one another, so you're left with just the function. the derivative of f, the integral of f, neutralize each other, you just have f. But it's evaluated at f of b minus f of a. Okay?
When the entire thing, like,
Yeah.
okay.
Okay? So for example, if I have, negative 1 to 2, f prime of x dx, this will just be f of 2 minus f of negative 1. Okay. Now, the other order is, if you have the derivative of the integral, then again, derivative of integral of the function is just the function. The derivative and integral neutralize one another. But, this x value comes here, and what most people forget is the chain rule. Okay? All right. Now, again, okay, so here we go. This is everything you need to know about position, displacement, velocity, and all that good stuff. Okay? So I don't think there is much I need to go over here. This one, right, speeding up and slowing down, people just forget. I don't know why people forget. But you have to say, for example, v of t is greater than 0 and, a of t is greater than 0 and so on. Okay? Okay, this one. Man, put like a huge star next to this one. Average value. This is the formula. I think I'm going to make you guys like recite these every day in class, like, just like randomly, like
Not a plus b divided by 2.
old school. No, no. Average value of f. Average value of f. What's more is this. What's more is this. If you have average value of f, it's that f that goes in here. This is different from average velocity where we use the position function. When you are finding average value of f, it's that thing that goes in there. Same function. Okay? So, take a look. Average velocity can be found using two ways. One, using the position. Two, using the velocity. Let me recap this. Suppose you want to find average velocity. Ask yourself, what am I given? If you're given velocity, use this. If you're not given velocity and you're given position, use that. Yeah.
So by saying average velocity, that's assuming the average rate of change.
Yeah.
So
Yeah. Okay? Yeah, but it depends. Yes, it's exactly the same thing, but now you have to look at what it is that you're given. If you want to find the average of a quantity, okay, are you given that same quantity? Then you use this. Like if you want the average rate of change,
That makes sense.
if you want the average rate of the velocity, right? If you want the average velocity, ask yourself, are you given velocity? Yes, then use this. If you're not given velocity, then you have to do it this way. Okay? People mix these up.
And same thing for acceleration.
Same thing for acceleration.
Nice. Oh, and if you're given x, which is just f of x, then you just do 1 over v minus x.
Uh-huh.
There's
Mhm.
nothing before.
Exactly. Okay, so total consumption, okay, if your given rate is the integral. Okay, area and volume, I think you guys are okay with that because it's the last thing we did. I mean, you're okay with the process, you just need to practice more,
Yes.
right? So like me reading this to you won't matter as much, I think.
In the past, when I would look at things from past chapters in math, I would have completely forgotten it. But like this doesn't seem too important.
Yeah, because we've still been doing it, Okay, so look. So let's talk about volume. let's talk about volume. If you have cross sections, the process is, right? Find area. Okay, so determine the formula for the area. Then you integrate the area. Okay, so if it's by cross sections, if it's solids of revolution, then you have to ask yourself, what is the axis of revolution? So ask, what is the axis of revolution? Okay, number 2, radius is from axis to function. Okay, number 3, you go top minus bottom, or right minus left. Okay, and then remember, then the volume has to be pi r squared, dx or dy. Okay, yeah.
And I think you just explained it.
Mhm.
Number 2, I also got confused a little. Okay, so it's on a cube. When do I know to subtract it? So the first one is f of x squared minus